Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to discuss the operation of different logic gates, which are AND, OR, NOT, NAND, NOR gates, which are usually the gates used in the electronic circuits for control of the systems. And here, I am going to discuss how these gates are used in the pneumatic systems to control it, and their input and what is the output, how those are controlled, that I am going to discuss here. First one in this AND logic gate, and that AND logic gate, which is also called as a AND function. That AND function, which is represented in the pneumatic circuits as a MPL components, moving part logic components, and also we are going to take the truth table for that and symbol of representation of this AND logic gates. In this one, MPL component, the MPL component moving part logic components, what are there? Here there are two inputs and one output we are going to get. The all are arranged in such a way that when in this AND gate, both inputs A and B are uh, higher, then the output will be higher. And for that, the supply of the air, whatever is there, if the both the these inputs given to the that valves that will be on condition, then the output we are going to get from it. The output represented in terms of the inputs A and B, that is Z equal to A into B. Here from this we can come to know that one any one of this A or B is 0, the output will be remains 0, and both are 0, always it will be 0. Therefore, output will be higher or a positive value that whenever the both are at a higher level. And that can be we are going to represent here in the inputs and output. This is the truth table which is represented in terms of the input what we are going to give. As I have discussed already in this one MPL components, both the inputs are uh, higher, then only the output will be higher. Any one of the lower, the output will be lower. Here we can see that one A and B both are lower, output will be lower. And the A is lower, B is higher, output will be lower. And A is higher, B is lower, output will be lower. Here A and B both are higher, the output will be higher, and that we can see here Z is equal to A into B. And that is symbolically represented like this A, B, and output will be A into B. And the symbol what we can represent logic symbol A and B output here it will be there. And this American National Standard Institute symbol which is used in this pneumatic circuits, this symbol is used for the AND gate. And here also we are going to in the circuit we are going to show the symbolically as a symbol of two pressure valve. Here the two pressure valve means both the pressures are at a higher level, the output we are going to produce. Here we can see here if it is the input and here also input, then this spool whatever is there it is at center position, then the flow will be taking place to the output. Okay, the flow will be taking place output. Anyone if it is lower and this higher, this will be pushes here that comes to your close one, then there is no output. There is no output here also, that it will be in the closure condition. That's why it is also called AND gate is also called as a two pressure valve. Moving to the next, that is the OR logic gate. OR means here any one A or B input, if it is higher, output will be higher. And that can be represented by the moving logic, moving part logic. That one component here, the air supply, what is there? That is supplied to A or it can be supplied to B. Any one, the output we are going to get from it. And the output is represented A plus B. Okay, A plus B means here the any one is a higher value which is represented that higher value only we are going to get from it. In the truth table we are going to represent usually this circuit's output or input we are going to represent in boolean values. The boolean values 0 or 1 we are going to use because here the in the computer uh, processing the input what are required for that one in terms of zeros and one only, zeros and one, that is a boolean values only. Whatever the program we are going to write, that will be converted in terms of the zeros and one in the computer, that will be executes like that. Here we are going to take in the electronic circuit, we are going to use this boolean values also. Here for this truth table, for the OR gate, there is a both inputs are lower, output will be lower. A is lower, B is higher, and output will be higher. A is higher, B is lower, output will be higher. If the both are A and B are higher, output will be higher. And that one we are going to take as a Z is equal to A plus B. And A, B, the output A plus B we are going to get in the symbolically we can represent. Logical symbol we can represent like this also. And American National Standard Institute symbol we can represent here. Here any one, this if it is a flow is there, then we are going to get the output here. And if this is coming and this is this whatever the uh, spool is there come to this position, then the flow will be taking place from this side. Any one input is there, the output supply of the air we are going to get from this using the OR logic gate. Next, moving to the third one, NOT logic gate. NOT means here the input is lower, output will be higher. If the input is higher, output will be uh, lower. Like this, it will be inverse of that input. The inverse of input we are going to get, and that's why here the input we are going to get here. If the input is lower, output we are going to get here higher. If the input is lower, higher we are going to get, and the input is higher, lower we are going to get. That is Z is equal to A inverse. A inverse means here we are going to get the A01 we are going to get like this. In the MPL component representation we are going to get like this. In the truth table, the input what is there, that is in terms of the zeros and one. If it is 0, 1 we are going to get, 1, 0 we are going to get. Symbolically it is represented like this. Here the NOT is represented at the output. Therefore, that is the NOT logic gate. And also it is symbol will represent like this. N is written here. N is means it is a NOT logic gate. And American National Standard Institute symbol like this, it is used in the pneumatic circuit. Moving further, next one is a NAND logic gate. NAND logic gate, it is a combination of AND and NOT gate. Combination of the and NOT gate. That means whatever the AND output we are going to get, inverse of that we are going to get here. Okay, that is represented by the moving part logic like this. Here the supply is there, that is going to supply to this one, and this supply is coming like this. Okay, here input if we are going to give through directly, it is any one. This is higher one, we are going to get the output, and if directly it is going one A is higher, then also we are going to get the this output is higher. If both are lower, then only we are going to get the lower value. That means exactly reverse of that AND logic gate output we are going to get in the truth table. Here we can see that inputs and output. Any one or both are lower, we are going to get the output higher. Okay, here both are lower, A and B, higher output we are going to get. And in A is lower, B is higher, also we are going to get the output higher. And A is higher, B is lower, output we are going to get the higher one. Both are higher, the output we are going to get the lower. And that is the what we are going to get. Z is equal to A into B in the AND gate. That is the inverse of that. Here the result we are going to get. The symbolically we are going to represent like this. Here the NOT will be there. Okay, that NOT gate and AND gate, that symbol we are going to represent. And also we can represent there is a combination of the and NOT gate. Okay, and output here, and this is not, we are going to get the A into B inverse of that output. The symbolically we can represent like this, or we can represent any one symbol. And the here this one also we can represent in the logic symbol. This is AND gate and this is NOT gate. The combination we are going to get. Here the whatever the here MPL circuit we have shown, that MPL circuit is like this. It is shown to get the output from it. This is about the NAND logic gate. And last one, NOR logic gate I am going to take. NOR means it is a combination of the OR and NOT gate. and what the output of the OR gate we are going to get, that inverse of that here we are going to get. Here both are uh, lower value, output we are going to get the higher value, and both are higher, we are going to get the lower. Any one higher, then also we are going to get the lower. Okay, here we can see that its flow is like this. When the both are lower, we are going to get the output here. Okay, that is Z is equal to A plus B inverse of that. That is the OR gate output. What is there? Inverse of that we are going to get, which is represented in the table in terms of the Boolean values. That is both inputs are lower, output we are going to get higher, and any one input is higher, then also we are going to get the lower here also, and both the inputs are higher, then also we are going to get the lower value at the output. And symbolically it can be represented, or output Z A is equal to A plus B. Inverse of that, the not symbol we are going to use, that is A plus B of inverse, and the OR gate and NOT gate. The both together also we can show in the symbol. Okay, that is about the NOR logic gate, what we are going to use in the circuit. And this is about the different types of the five logic gates I am discussed, and are not NAND and NOR logic gates, which are used in the pneumatic circuits. And particularly I am going to use these and, or, and not, nor, okay, all these gates. By using that, how the circuit works, I am going to take in further sessions. And also the some other logic gates. There is a memory valve, and also time off, time on, and flip flop, like that. Another four the gates are there, which are used particularly in the pneumatic circuits. Those also I am going to discuss in the further sessions. Thanks for watching. If you like, share, subscribe, and comment.